On July 1st, a small telescope in Chile caught something moving across the sky faster than anything astronomers had ever tracked before. Within hours, the calculations were confirmed, and scientists realized they were looking at only the third object ever discovered that came from outside our entire solar system. It did not start near our Sun. It did not begin anywhere close to Earth or Mars or Jupiter. It began around a completely different star, somewhere else in our galaxy, and it had been drifting through empty space for longer than human civilization has existed, before finally crossing paths with us. Its name is 3I/Atlas, and what scientists have learned about it since that first sighting is stranger, more genuinely mysterious, and more scientifically important than almost anything reported about it in the following months. Let's get straight to the numbers, because the numbers alone are enough to make your head spin. When it was first spotted, 3I/Atlas was already moving at a jaw-dropping speed, fast enough that it could never be captured by our sun's gravity. Comets and asteroids that belong to our solar system move in loops, locked forever in orbit around the sun. This object was doing the opposite. It came in on a straight, hyperbolic path, swept close to the inner solar system, and is now leaving again, never to return. Scientists quickly confirmed this using basic orbital mechanics, the same math that has predicted comet paths for centuries. There was no ambiguity here. This thing came from outside, and it is going right back out. Estimates of its age are almost impossible to fully process. Based on its incredible velocity and the physics of how objects get ejected from other star systems, researchers believe 3I/Atlas could be billions of years old, meaning it may have formed around a star that existed long before our own sun even ignited. Think about that for a second. This chunk of ice and rock has been drifting silently through the black emptiness between stars for a length of time that makes all of human history look like a single second. And it just happened to cross through our neighborhood at exactly the right moment for us to catch it with modern telescopes. As soon as it was confirmed as interstellar, nearly every major observatory on Earth and in space turned toward it. Hubble captured a glowing, teardrop-shaped cloud of dust surrounding its icy core. The James Webb Space Telescope, humanity's most advanced eye on the universe, studied its chemistry in incredible detail. The Sphere-X Space Observatory joined in too, along with ground-based telescopes across multiple continents. This was not a quiet, ignored event. This became one of the most intensely observed objects in the history of modern astronomy, precisely because interstellar visitors are so rare that scientists may only get a handful of chances like this in an entire lifetime of research. Here's where it gets genuinely interesting. As 3I/Atlas approached the sun, it began behaving in ways that surprised even veteran comet scientists. Its coma, the bright cloud of gas and dust surrounding its core, grew unusually large and unusually active. Spectral readings picked up strong carbon dioxide production, more than expected for a comet at that distance from the sun, along with later detections of water vapor and even methane, a discovery announced only a few weeks ago that immediately made headlines in the scientific community. Finding methane on an object that formed around a completely different star gives researchers a genuine physical sample of chemistry from another solar system entirely, something that has almost never been directly measured before. Before we get to the Mars flyby, it helps to understand exactly why chemists got so excited about the gases coming off this thing. Every comet leaves a kind of chemical fingerprint as it approaches the sun and starts to warm up, since the heat causes frozen ice and trapped gases inside its core to boil off into space, forming that glowing coma and long tail we associate with comets. Most solar system comets show a fairly predictable mix of water, carbon dioxide, and a handful of other common compounds. When early readings from 3I/Atlas showed unusually strong carbon dioxide output relative to water, long before it even reached the sun, some scientists took that as a signal that this object might have formed in a colder, more distant part of its home star system, similar to how far-flung objects in our own solar system tend to behave. Then, as it got closer to the sun and warmed further, water production increased as expected, eventually becoming the dominant gas in its coma, which matched general patterns seen in solar system comets, even while the specific ratios stayed somewhat unusual. The methane detection announced only weeks ago pushed this even further. Methane is a genuinely exciting molecule for scientists studying the origins of planetary systems, since it is one of the basic organic building blocks involved in the kind of chemistry that eventually leads to more complex molecules. Finding it clearly embedded in material from an entirely different star system gives researchers something they have almost never had before: a direct, measurable sample, proving that this same basic chemistry exists elsewhere in the galaxy, not just in theoretical models or computer simulations. It does not prove anything about life. Nobody serious is claiming that. But it strengthens a growing scientific picture, suggesting that the raw chemical ingredients needed for planets, and potentially for life, may be far more widespread across the galaxy than researchers assumed only a decade ago. Then came the images. In October, spacecraft orbiting Mars got an extraordinary opportunity. As 3I Atlas swept past the red planet at a distance of about 29 million kilometers, several Mars orbiters were perfectly positioned to observe it up close, far closer than any telescope on Earth ever could. NASA's Mars Reconnaissance Orbiter captured detailed images using its high-resolution camera. Europe's ExoMars Trace Gas Orbiter photographed it too, in what scientists called an extremely difficult observation, since the comet was tens of thousands of times fainter than the instrument's usual targets. Even China's Tianwen-1 spacecraft, which has been quietly orbiting Mars for years, managed to capture the interstellar visitor as it passed by. These Mars-based observations turned out to be scientifically priceless. By combining the data seen from Mars with data seen from Earth, scientists were able to triangulate the comet's exact path with 10 times more precision than before. This is actually one of the quiet triumphs of this entire story. Engineers realized that having a second observation point, literally on another planet, gave them a completely new tool for understanding the trajectory of objects flying through our solar system, something that could prove genuinely valuable for future planetary defense work involving asteroids or comets that might someday pose a real threat. And to be absolutely clear about the number that matters most here, 29 million kilometers. That is how close 3I Atlas came to Mars at its nearest point. That is roughly 75 times the distance between the Earth and our own moon. There was never any risk of it striking Mars, and every space agency that tracked it, NASA, ESA, and the China National Space Administration, confirmed the exact same thing using independent data. This was a spectacular flyby, not a near miss, and definitely not a collision course. After its closest approach to Mars, the comet continued inward toward the Sun, reaching its closest solar approach at the end of October, at a distance placing it just inside the orbit of Mars itself. For a short window, it passed almost directly behind the Sun from Earth's point of view, making it impossible to observe from our planet. Scientists had to simply wait patiently for it to swing back into view on the other side. When it finally reappeared in December, telescopes locked back onto it immediately, hungry for every last piece of data before it faded from view for good. Now here's where the story picks up a controversial edge, because not every scientist studying 3I Atlas agrees on how to interpret everything they are seeing. Harvard astrophysicist Avi Loeb, a well-known and sometimes controversial figure in the search for signs of extraterrestrial technology, has published a long list of observations he describes as genuine anomalies. He has pointed out that the comet's path lines up unusually closely with the orbital plane of our planets, a geometric alignment he calculates has only a very small statistical chance of happening by pure coincidence. He has also highlighted its unusually close approaches to both Mars and later Jupiter, and its timing, which placed it out of view from Earth during its closest pass by the Sun. Loeb has openly speculated that these patterns are at least worth studying carefully as a possible sign of something more than a simple natural comet. Loeb has laid out his case in a long-running series of public posts, walking through what he numbers as more than 20 separate observations he considers individually unlikely. From the comet's brightness appearing to pulse on a regular rhythm at one point during its approach, to its unusually large size compared to earlier interstellar visitors, to the specific timing that kept it hidden from Earth-based telescopes during the exact window when it passed closest to the Sun. He has been careful to frame most of these as open questions rather than firm conclusions, repeatedly saying that the honest scientific answer requires more data before anyone can draw a confident conclusion either way. Even so, his public profile means that every one of these individual observations tends to get amplified far beyond how the broader scientific community actually weighs them. To be fair to the full picture, it is important to say clearly that the overwhelming majority of astronomers studying 3I Atlas disagree with that extreme interpretation. NASA, ESA, and independent research teams around the world have repeatedly stated that every property observed in this object, its glowing coma, its icy nucleus, its gas jets, its dust tail, and its chemical composition, is fully consistent with natural cometary behavior. No instrument on any spacecraft from any country has detected anything resembling artificial technology, engineered materials, or engineered signals. The scientific consensus remains firmly that this is a real, natural, ancient interstellar comet, even while a small number of researchers continue raising questions about specific details they find statistically surprising. That tension itself is part of what makes this such a fascinating story. Science does not always move forward through total agreement. Sometimes it moves forward through exactly this kind of respectful disagreement, where the vast majority of a field holds one well-supported position, while a smaller number of scientists push back and ask uncomfortable questions, forcing everyone to look at the data more carefully. Whether or not Loeb's specific alignment concerns ever amount to anything, the process of testing and retesting this data is exactly how real science works, and it has genuinely sharpened how carefully researchers are tracking this object. As 3I Atlas moved further from the Sun in the early months of this year, astronomers noticed it had not broken apart the way some smaller comets sometimes do when exposed to intense solar heating. Instead, follow-up observations using Hubble allowed scientists to separate the faint glow of its solid nucleus from the surrounding cloud of dust for the first time, giving a much more precise estimate of its actual physical size. Current measurements put its core at roughly 2.5 kilometers across, making it considerably larger and apparently more massive than the previous interstellar visitor discovered back in 2019, a comet known as 2I Borisov. That makes 3I Atlas not just the third interstellar object ever found, but likely the largest and most massive one confirmed so far. Getting an accurate size for any comet is genuinely difficult, because most of what telescopes actually see is not the solid core at all, but the surrounding glow of dust and gas that can be hundreds or even thousands of times larger than the icy nucleus hiding inside it. Early estimates released shortly after discovery had to rely on brightness alone, which gave a fairly wide range, with some calculations suggesting the core could be anywhere from under a kilometer across to several kilometers wide. It was only after the comet passed behind the Sun and re-emerged, giving astronomers a chance to watch its coma settle down somewhat as it moved further from peak heating, that Hubble was able to isolate the faint point of light coming specifically from the solid nucleus itself. That careful separation of nucleus from coma is what finally allowed scientists to settle on the more confident 2.5 kilometer estimate, a number that will likely keep getting refined slightly as more data comes in during the final months before the comet fades from view completely. By March of this year, the comet made its closest approach to Jupiter, passing at a distance of a little over 53 million kilometers, remarkably close to the boundary of Jupiter's gravitational zone of influence, a boundary scientists call the planet's Hill sphere. Researchers monitoring the flyby confirmed that Jupiter's immense gravity nudged the comet's path slightly, a completely expected and normal effect for any object passing that close to such a massive planet, but not one that threatened Jupiter or any of its many moons in any way. From here, 3I Atlas is now fading fast, both in brightness and in visibility, as it continues its long journey back out into the emptiness between the stars. Let's talk about what this actually means for us, because interstellar objects like this are not just pretty pictures for a telescope. They are physical samples of material that formed around another star entirely, delivered to our doorstep completely free of charge, without needing a single rocket launch. Every reading of gas, dust, and ice coming off this comet gives scientists real clues about the kind of chemistry that exists in other planetary systems, information that is normally locked away, impossibly far beyond the reach of any spacecraft we could ever build and send there ourselves. Discoveries like the recent detection of methane are not just interesting trivia. They are direct evidence that the raw ingredients found in our own solar system, water, carbon dioxide, and simple organic molecules, also exist in at least one other corner of the galaxy, hinting that the building blocks of planets, and maybe even life, might be far more common throughout the universe than we previously assumed. There's also a quieter, more practical lesson hiding inside this entire event. For decades, planetary defense researchers have worried about how quickly humanity could detect and track an object that suddenly appears from deep space on a fast, unpredictable path. 3I Atlas became an unplanned, real-world test of exactly that scenario. Telescopes on Earth spotted it almost immediately after it entered detectable range. Multiple space agencies coordinated observations across different instruments and even different planets within days. And using nothing more than basic physics and careful measurement, scientists nailed down its trajectory with remarkable precision long before it ever reached the inner solar system. If a genuinely dangerous object ever does appear on a similar hyperbolic path someday, this entire episode proved that our current global network of telescopes and spacecraft is far more capable of tracking it than most people probably realize. It is worth remembering that the very telescope that first caught 3I Atlas, the Atlas survey based in Chile, was originally built for exactly this kind of planetary defense purpose, scanning the sky night after night, specifically to catch fast-moving objects before they get anywhere close to Earth. That system worked exactly as designed here, catching an object while it was still hundreds of millions of kilometers away, giving scientists months of lead time to study it in detail rather than being caught by surprise with only days or hours of warning. The fact that this particular object turned out to pose no danger at all does not make that early detection any less valuable. Quite the opposite. Every successful early detection, even of a harmless comet like this one, is a live rehearsal for the day when an object might not be so harmless, and getting that rehearsal right matters enormously. It is also worth remembering just how rare an event like this truly is. In all of recorded human history, we have only confirmed 3 objects definitively coming from outside our solar system. The first, discovered back in 2017, was a strange, elongated object named Oumuamua that tumbled through our solar system so quickly that astronomers barely had time to study it before it vanished from view, leaving behind years of debate about its true nature. The second, 2I Borisov, arrived in 2019 and behaved much more like a classic comet, giving scientists their first confirmed look at genuinely interstellar cometary material. Now, 3I Atlas has given us our best, most detailed, most heavily observed look yet, thanks to how much stronger and more numerous our telescopes and spacecraft have become in just the past few years. Oumuamua, in particular, sparked years of scientific back and forth precisely because it was discovered so late in its approach that telescopes only managed to observe it for a matter of weeks before it became too faint and too distant to study further. That short window left key questions permanently unanswered, including exactly why it appeared to accelerate slightly as it left the solar system, an anomaly that some researchers attributed to gentle outgassing too faint to detect directly, while a small number of others, including Loeb himself, suggested it might hint at something more unusual. That earlier, unresolved debate over Oumuamua is part of why scientists were so determined to observe 3I Atlas as thoroughly and as early as possible this time around, giving themselves months rather than weeks to gather data and hopefully avoid leaving the same kind of open questions behind. Each of these three visitors has taught us something new, and each arrived on a completely unpredictable schedule, since nobody on Earth can forecast when the next interstellar wanderer might drift into view. That unpredictability is part of what makes this field so thrilling for astronomers. There is no way to plan years in advance for a discovery like this. All researchers can do is keep building better telescopes, keep scanning the skies every single night, and stay ready to react the moment something unusual shows up moving just a little too fast to belong here. So where does 3I Atlas go from here? Having already swept past Mars, the Sun, and Jupiter, it is now heading back out toward the edge of our solar system and beyond, retreating along a path that mirrors almost exactly how it arrived. Within the next few years, it will cross beyond the outer planets and disappear into interstellar space for good, continuing its silent journey between the stars, most likely never to be seen by human eyes again. Whatever data we managed to collect from it in these final months of visibility may be the very last information we ever get about this particular ancient traveler. What's left behind, though, is an enormous amount of real scientific value. Astronomers now have detailed chemical readings, precise trajectory measurements, high-resolution images from multiple planets, and an ongoing scientific debate about a handful of genuinely unusual orbital details that some researchers still consider worth investigating further. Even if the overwhelming consensus remains that this is a completely natural comet, and every serious space agency studying it agrees that it is, the process of tracking, measuring, and debating an object like this from the moment of discovery all the way to its final disappearance is exactly the kind of real, functioning science that rarely gets the attention it deserves. There is something quietly humbling about all of this, too. For a few short months, humanity's most advanced instruments, telescopes worth billions of dollars, spacecraft orbiting other planets, and some of the sharpest scientific minds on the planet all turned their attention toward a single frozen wanderer that had been drifting alone through the galaxy for possibly billions of years before we ever noticed it. It did not know we existed. It was not aiming for us, or for Mars, or for anything at all. It was simply following the same laws of physics that govern every rock, every comet, and every planet in the universe. Laws that happened to bring it close enough for us to finally look up and see it. And maybe that is the real story here, more incredible than any invented collision or hidden signal ever could be. An object older than our own sun, born around a star we will likely never identify, drifted silently through the emptiness of space for an almost unimaginable stretch of time, only to pass briefly through our own cosmic backyard at exactly the moment human beings had finally built the tools capable of noticing it, studying it, and understanding a little more about where we all actually come from. Consider the sheer improbability of the timing involved. Human beings have only had telescopes capable of reliably spotting a faint, fast-moving object like this for a few decades at most, and space-based observatories like Hubble and Webb for an even shorter window than that. Stretch that against the billions of years 3I Atlas has likely spent drifting through the galaxy, and the odds that it happened to cross our solar system during this exact narrow sliver of human technological history feel almost absurd. A few thousand years earlier, and it would have passed by completely unnoticed, a silent shadow slipping past an Earth full of people who had no way of ever knowing it was there. A few thousand years later, and perhaps we would have had even more advanced tools waiting for it. Instead, it happened right now, in our own lifetimes, giving an entire generation the rare chance to watch a genuine visitor from another star system in real time. If you found this breakdown genuinely fascinating, that is exactly the kind of real space story this channel is built around. Interstellar visitors like this do not come around often, and every single one of them teaches us something new about the wider universe we're all quietly floating through together. Subscribe if you want to stay updated the moment the next unusual object gets spotted heading our way, because somewhere out there, another ancient traveler is almost certainly already on its way, and nobody knows exactly when it will arrive. Given that we have now confirmed 3 of these interstellar wanderers in less than a decade, many astronomers expect the pace of discovery to keep accelerating as newer, more sensitive survey telescopes come online over the next few years. Each new instrument added to the global network improves the odds of catching the next visitor earlier,